Dua door prize nanti akan disampaikan bagi para pengisi presensi dan akan diumumkan pada akhir sesi nanti. Dua door prize selanjutnya akan diberikan untuk petanya terbaik dan akan diumumkan setelah sesi. Untuk door prize terakhir akan diberikan bagi peserta dengan nilai asesmen terbaik dan tercepat. There will be 5 door prizes that will be given to 5 participants, which are wireless mouse presented by Archichat. The first 2 door prizes will be given at the end of the session to 2 lucky participants. Another 2 door prizes will be given to the participant which has the best inquiry and will be informed after the session. The last door prize will be given to the participant which has the best assessment score and is the quickest to do it. Baik, sebelum acara dimulai lebih lanjut, akan ada beberapa kata sambutan dari Bapak Lodi selaku perwakilan dari PT Piranti Nusantara Teknologi. Kepada Bapak Lodi, waktu dan tempat dipersilakan.
Baik, terima kasih Pak James atas invitation-nya. Oke, perkenalkan, selamat siang Bapak Ibu, Om Swastiastu, Namo Buddhaya, salam kebaikan. Para peserta yang terhormat, perkenalkan saya dengan Lodi dari Divisi Produk PT Piranti Nusantara Teknologi atau disebut Piranusa ya, sering disebut piranusa.com, yang merupakan partner dari Graphisoft untuk produk BIM di Indonesia, BIM Archicad ya di Indonesia. Pertama, kami mengucapkan terima kasih atas kesempatan yang diberikan oleh ICI ITB untuk kerjasama dalam pelaksanaan workshop bertema BIM6 di Building Energy Use. Kami juga berterima kasih kepada Archilantis, berterima kasih kepada para peserta yang telah menghadiri acara ini. Ya. Nah, PT Piranti Nusantara Teknologi, kami bergerak di bidang teknologi informasi dan perangkat lunak, khususnya bagi industri architecture, engineering, and construction. Di antara produknya adalah ada ZPCAD, BIM Archicad, Aptar, Enscape, dan Twinmotion ya untuk render dan visualisasi. Nah, pada kali ini memang temanya ini berkaitan dengan ini ya, asalnya sebetulnya perkembangan ilmu pengetahuan teknologi ya. Itu memang telah terjadi sangat pesat, itu karena siklus ilmu pengetahuan yang menghasilkan teknologi ya, dengan siklus yang berkelanjutan, yang memungkinkan terjadinya integrasi antara ilmu pengetahuan dan teknologi di berbagai bidang, khususnya dalam ilmu arsitektur, civil engineering, manajemen ditambah dengan teknologi informasi. Nah, dari situ juga menghasilkan sebuah metode digital ya yang dikenal dengan istilah Building Information Modeling. Nah, dalam tema 6G Building Energy Use ini merupakan termasuk Building Information Modeling. Jadi bagaimana membuat kita bisa membangun tanpa harus memiliki dampak negatif ya terhadap lingkungan. Jadi bangunan hijau melestarikan sumber daya alam, mengurangi dan bekerja untuk menghilangkan dampak negatif terhadap iklim dan lingkungan kita. Hal ini kita bisa memulai untuk membangun masa depan yang berkelanjutan dan juga demi kenyamanan kita semua dan masyarakat ya. Salam sukses, semoga acara ini berjalan dengan baik dan lancar. Terima kasih atas kesempatan yang diberikan. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, selamat mengikuti acara ini. Terima kasih.
Baik, terima kasih kepada Bapak Lodi untuk kata sambutannya. Nah, untuk sebelum memasuki sesi pemaparan materi, izinkan saya untuk membacakan aturan yang berlaku selama keberlangsungan workshop ini. Di antara lain, peserta menggunakan display name dalam Zoom workshop dengan format institusi _ nama lengkap dengan contoh ITB _ Uzair Adli. Peserta juga diharuskan untuk berperilaku sopan saat workshop dilaksanakan. Peserta juga diharapkan untuk mematikan suara selama proses pemaparan berlangsung. Peserta hanya dibolehkan mengaktifkan suara setelah dipersilakan oleh moderator. Peserta yang memiliki pertanyaan terkait teknis sesi dapat menanyakan hal tersebut kepada host atau co-host dalam meeting ini. Peserta juga diwajibkan untuk berbicara menggunakan bahasa Indonesia yang baik dan sopan dan tidak mengandung unsur sara saat mengajukan pertanyaan. Peserta diwajibkan untuk mengisi link presensi awal dan feedback yang akan dibagikan pada akhir sesi workshop. Kedua link ini akan dibuka sampai pukul 16.00 WIB. Peserta akan mendapatkan assessment yang berupa pertanyaan di Google Form yang akan diberikan pada akhir sesi. Peserta diberikan waktu 1 kali 24 jam untuk mengisi form assessment yang diberikan. Peserta diharapkan untuk menjaga privasi pembicara dan tidak menyebarkan luas rekaman, modul pelatihan, serta tautan grup WhatsApp melalui media apapun. Jika terdapat masalah terkait workshop, peserta dapat menghubungi narahubung. Di gambar. Untuk pertanyaan terkait materi yang disampaikan pada sesi ini, dapat ditanyakan ke dalam link Slido yang tertera di layar, dan jangan lupa juga untuk menuliskan nama lengkap dalam Slido agar mendapatkan kesempatan memenangkan door prize. It is now my pleasure to introduce our speaker for this second session of BIM workshop, that is Mr. Sandor Bali, who is known as the BIM consultant for Graphisoft. For those of you who aren't familiar with Mr. Sandor, he is the BIM implementation architect and Graphisoft registered consultant. He also has a Master of Science degree in architect and engineer, and has a bachelor degree in constructing architect. So without further ado, Mr. Sandor, the screen is yours.
Thank you. Okay, hello everyone, welcome. I hope you can see me now, and then I can start sharing my screen. Okay. All right. So I hope you can see the PowerPoint, and then we can get started. All right. So welcome everyone. Once again, it's a great pleasure to be here. So let's take a look at the green building design solutions, energy use, BIM and energy use in a short session. I'll go through the theory a little bit, the workflow, what we use in ArchiCAD, and I'll also show you ArchiCAD itself as well, just to click around a little bit. So, okay. So the first thing is, why are we dealing with green building design, and can we really do it? Well, of course there are incentives. So it's basically, one thing is that it can be required by the owner for certification to have a certified building, that it has a good and efficient energy usage. But it can also be a mandatory requirement by the local building code that you have to prove that there's the minimum energy performance of your building. Besides, it might be just the incentive of the practice of its own to impress the client, to ensure that they are providing a better design for the client. Also, in case of, let's say, when we talk about architects, we can have more informed decisions, and you know, if we have some data behind our design, then we have a stronger stand against the engineer, so we can better justify our solutions. And all in all, if we can provide all these, then between the different practices, we can have definitely a competitive advantage from a business point of view. But of course, on the other hand, that there are some deterrents. So obviously not everyone is doing green building design. Obviously, it's happening more and more. But why it's not happening? Probably one thing is that it can be considered too complex, too complex in general. So especially for an architect, you have to know a little bit more than the basics of the building physics. There's a lot of administrative part about the certification, the documentation, the formats. So in general, it might not be for architects. And usually it needs some additional tool, additional software. So you have to spend more time learning it, not just the software, but learning the certification process, and so on and so forth. So obviously there are some pros and cons in this whole approach, but let's see where we stand now, and then hopefully the incentives will be good enough for you in the future, and we can minimize the deterrence. So first of all, again, why do we have to deal with all these things? Well, this is a relatively older slide, so probably nowadays you don't really have to over-explain why we have to think about sustainability. But even compared to like maybe a year ago, things have changed a lot. So we have a clear energy crisis on top of our shoulders. So that on its own can be a very good reason. But on the other hand, we as architects have to be responsible for it as well, because the buildings construction sector, the residential, commercial buildings, together actually are responsible for 30 to 40% of the final energy consumption, and actually around 30% of the total emissions as well. And what's the reason for this? Well, obviously the demand is growing and the energy usage and the numbers are growing year on year as well. And one reason can be that the developing countries have now new demands. We have bigger buildings, so bigger floor area. We own more devices, more energy consuming appliances as well. And even as I mentioned, so like if we're thinking about the climate change, then global warming, if you just think about your own countries or just local countries, Singapore, Indonesia, Philippines, Thailand, then there's a growing demand of air conditioning as well, and a growing demand of cooling. So obviously this on its own will just raise this ratio. And as architects, we are pretty much responsible for making things a little bit better by reducing the emissions and having our buildings performing better. So when you look at the building life cycle, then basically all stages will be participating in this consumption. So it starts right away from the raw material acquisition, and it's not just basically the design and the construction when we have to think about the energy performance. And actually, when we have the main environmental impact is the operation cycle or the operation phase within the life cycle, especially because that takes the longest time. So if you just take a look at the amounts, let's say the vertical amounts, the cost, the primary energy usage, and the emission, then you can see that during the acquisition phase, construction phase, we have actually higher numbers than during the operation and the maintenance, which is the actual usage of the building. But if we also look at this diagram or graph in an actual scale, then you can also see that this part, the building operation, is actually spanning over 50 years, which even though it's a lower amount at each segment, but on a longer scale, it actually matters much more, and means more energy usage and energy demand than during the acquisition, construction, design, and so on, the early phases or the renovations, decommissions. So that's why we also have to look into this, because our buildings will stay here for at least 50 years, or usually that's what we aim for. And if we have a bad solution, then it is going to stay with us for quite some time. So our goal with our tools, and pretty much I should say that this is the goal of all the energy evaluation tools in the BIM applications, or among the BIM applications, is to make sure that we support the design decisions from the early phases of your design. So how does this look like? Basically, okay, the first thing is that why we are doing this on the software part is because the Our sector is actually one of the largest energy consumption sectors, as I mentioned before. But the good thing is that with the correct design, we can make the most cost-effective changes as well. So a good design on its own will have the most cost-effective reduction in the energy consumption. So this is deducted by IEA, the International Energy Agency, which is an autonomous intergovernmental organization that provides policy recommendations, data, research, analysis on the global energy sector. And it's focusing on curbing carbon emissions and to reach global climate targets. It has 31 member countries and 11 associate members. And the thing is that all these countries contribute to 75% of the global energy demand. So again, that's a pretty huge number. Okay, so according to them, how can we reduce the energy consumption of our buildings? So, well, the first thing is that we mandate it. So we put together regulations and codes which will require a certification to prove that there is a lower energy consumption, and we make this mandatory. The other thing is that there are voluntary standards such as green building. So this refers to the construction, can refer to the construction itself, but it can also mean that the operation and the life cycle of the building is going to be sustainable. And this one is totally voluntary, and this is the part probably which I mentioned in the incentives, that this is a good way to impress the client and the general public that we have a certification that we fulfill green building standards and so on and so forth. And actually, this is the last one, that there are those rating systems which will effectively compare the different results to each other so that we can have different levels of certifications as well. So if we think about green building design in ARHICAD, it's not just the generic things. Okay, then we're going to have three objectives. So the first thing is to estimate the building's primary energy demand. So primary energy is basically the overall energy usage that we have on the environment. So it's basically the environmental impact as a whole. I will explain a little bit more about in the next few slides as well. In order to define this, we need to issue energy performance reports. So we have to examine our building and we have to create a report to show this result. Then if we have our building, then we have to make sure that we can analyze our results and understand what contributes to the energy consumption. So basically, it's not just that we have an actual end result, but we have to have a breakdown where we can see which of the consumptions are the heaviest or the lightest, which is worth looking into improving, and so on and so forth. And the last one should be that once we have different options and we think that we improved our design, then we should be able to compare these different versions and again make the decisions based on the report. So we have different design options, we can compare them, and then we can choose that from a sustainability point of view, which one is going to be the way to go. Okay, so as I mentioned, the primary energy just before, and that it's having the overall impact on the environment. So basically, when the energy is processed, there are different energy sources, and they all work differently, and they are all processed differently. So it means that they have different utilization factors and different impact the environment. We weigh energy consumption differently. way with regard to the environmental impact. And so what these losses can be is the energy industry losses, basically like mining, transportation, when it's like processing, or even when it gets to the actual end user. When it goes through the system, then there are losses within that system as well. And of course, we can see that how much the building demands, how much energy it demands, but we have to calculate with these losses to see what is the actual impact on the environment. So here is just an example of a coal to electricity conversion. So basically the 100% which we start with, the coal as it gets to the factory out of the mine, basically it gets down to 3% of the original energy when it's used as a light bulb. Of course, it depends on the type of the light bulb as well. We are going to look into that as well. But basically, you can see that there can be huge losses, and it's not enough just to say that how much we're going to actually use with the light bulb, because the globe is demanding much more, and we're going to have a bigger footprint than this one. And it's a very interesting thing. Well, later on, there are going to be these so-called primary energy factors, which are those factors that are weighing in the different energy sources in our energy consumption calculations. And it's very interesting to see. So, for example, if you are using renewable energy resources, hydro energy, like in Scandinavian countries, northern countries, then that has a lower impact on the environment. If you're using the coal to produce electricity, then it has a higher impact on the environment. So we'll have a part in ARHICAD as well where we can take these into consideration as well. Okay, so what is needed when we're thinking about the sustainable solution? If we look at the different phases of your building design, there we have schematic design, design development, and construction documentation. So in the first phases during the schematic design, basically what we're going to provide is purely architectural, pretty much, massing, orientation, zoning, and defining the building materials, maybe not in the very first phases, but as the design progresses, we're going to define the building materials, which already have some physical attributes. In the design development, we should already be able to define our low energy building design, meaning what is going to be the low energy consumption and what is going to be the sustainable solution, at least, first version. And then later on in the construction documentation part, or at the last phases, almost in this design phase of the building, first we can process our building energy model to third parties for certification, for energy certification. And also, as part of the documentation, we need to submit the performance rating documentation itself. So basically, these are the parts where the sustainability should be considered. It goes through the whole design phase in a sense. So let's see what we can include in these. Okay, so what is going to be our energy analysis workflow? Okay, so the first thing is that in ARHICAD, we're going to prepare the model, right? So this means that we have already had an initial design. We have our building elements created. And once we have that, we're going to put in energy-related data. So this can be climate information, environmental information, more details about our building elements, things like that. All that kind of information that normally, from an architectural design point of view, we wouldn't really put into the model. And basically, if we have this information, then we can switch to the building energy model view. So there is a BIM model, or the building information model, and there is the building energy model, which can be used for evaluating the energy performance. So then we're going to do this for the first time, and this is going to be our baseline design. So it means that this is the very first standard. This is the one that fulfills the standards, that fulfills the local requirements, but it doesn't really do much more than that. So we will use this as a baseline design and add the improvements on top of this, and we will see how they are going to work differently, basically. Okay, so there's a baseline design. We're going to add improvements. We read the report, we understand what contributes to the energy consumption, and we're going to improve the design. And then we can compare the baseline with the improved building energy model. We can, again, do an energy performance evaluation. So then we can say that we have actually a design option compared to the baseline design. Okay, so we can compare these two. This is going to be very important, that at the end of the process, of course, it's always possible to compare, just put two PDFs side by side, but we can have comparative tables as well, which is clearly going to tell us how much we improved, or maybe parts where we are not performing that well with the new design options. And if you have this improved building energy model, then again, as I mentioned in the previous slide, we can export that for certifications, certification needs as well. Okay, so how does this look here in Archicad? So let's say this is our BIM model, and you can see that this has the building, the surroundings. Basically, we try to model as much as possible, and the relevant parts, which, I mean, relevant in terms of the energy evaluation, because, for example, later on when we do the actual calculation, we're not going to show internal furniture or things like that, because they do not contribute to the energy use, in a sense that they don't, how to say, they don't act like the envelope of the building, that it affects what happens between the environment and the internal conditions. Of course, internal equipment, devices, appliances can contribute and will contribute to energy consumption, but we will put this into the model in a different way, and not by modeling the objects. So once we have the model, then we're going to generate the view, which only contains the elements that are relevant for the energy demand calculation. And then we're going to put in this energy related information that I just mentioned. So this can be the creation of so-called thermal blocks, putting in zones into the building model. So zones are going to be our rooms and the spaces within the model. And once we have those zones, we can organize them into the thermal blocks. So, for example, the different rooms that contribute or work as offices will be collected into an office thermal block. And typically these thermal blocks, they have the same orientation, they have the same operation profiles. So it means that they function the same way. They have the same internal requirements, therefore. So again, like for example, an office has a different internal requirement than a storage room, obviously. We don't necessarily have to have a nice temperature in the latter one. And also those rooms that belong to the same thermal block will have the same building systems. So whether that's heating, whether it's cooling, ventilation, or renewable systems or anything like that. Okay, so this is the environmental inputs which you can put in ArchiCAD. So how do we know where our project is going to function? Basically, there's one thing that when you provide your project location in ArchiCAD, then you're using latitude and longitude coordinates. So based on that, ArchiCAD can right away download the climate source file from the Strusoft server. So the Strusoft is a Swedish company who develops the VIP engine that we're using in ArchiCAD to do the energy calculation. So Strusoft has its own standalone energy evaluation tool as well. And they have this climate data server, so ArchiCAD can directly get the information based on the location coordinates. However, it's also possible to use other international standard climate data files. So one of those is the EPW format file. And these files can be downloaded from the website of, they can be downloaded from a lot of sites, but probably one of the most referenced ones is the Department of Energy from the United States. Basically, that's the EPW is an Energy Plus weather file. So Energy Plus is also an open source engine that is used in many cases for energy evaluation. So we can read this. It's a very standard format, and this includes the climate information. So what is on the external side of the building? We can add additional settings which may not be available from the model itself. So, sometimes you have a terrain, sometimes you don't have a terrain, sometimes you have surrounding buildings, but maybe you don't have them modeled. So even those factors can be considered. Here we need to have a little bit of knowledge about building physics and the values, but if you just leave them as defaults, then again, still you can compare different design versions just as efficiently. What is interesting is the wind protection and the horizontal shading. So there are two things that we can put here, how much these different directions are protected by the built environment surrounding our building. So the other thing is what I mentioned is the thermal blocks. So here we have the zones, and here we can choose in this palette a view where we can make the whole model as in a wireframe view, and then we can put in the just group the different zones in different thermal blocks. So what is a thermal block about? As I mentioned to you previously, if rooms belong to the same thermal blocks, it means that they work the same way, they function the same way. So for example, if we have the meeting thermal block, the meeting room thermal block, then we can choose from a preset meeting, conference, or seminar room. These have their standard human heat gain values, service hot water load, humidity load values, and we can choose daily schedules as well. So of course we can differentiate work days, non-work days, or for example, in case of classrooms or schools, we can differentiate when we have actual teaching or when we don't have teaching, when we have school breaks, recess week, similar things. So obviously then the demands are different. And what happens is that if I choose to have a daily schedule, for example, what happens on work days, then I have here the daily profile editor where I can set that from 7 a.m. to 6 p.m. we should have the temperature, the internal temperature between 20 and 26 degrees. So this is going to be the internal climate requirement or the internal functional requirement. This is what we want to achieve. But on the other hand, we will have to define also what is already put into the system. So occupancy count will be given based on the area per capita. So in this case, you will have to calculate back from the number of people that are within a room and just divided by the area of the room. Lighting, equipment, these are built-in standard numbers, and you can look up certain guides if you have some very special thing happening in these rooms. But even if you just use the built-in presets, then these will be set according the international standard numbers. So later on, these are going to be the things that we will change to see if there is an improvement. Okay, so before we do that, okay, I will just go into Archicad. I'm just asking for some help. I think I have to resume sharing. I don't know, when I switch to Archicad, it tells me that screen sharing is paused. Do you see Archicad now? Can I get some feedback from that?
Not yet.
Not yet. Okay, then that's interesting. Okay, I will stop sharing and share Archicad, and then we'll see if if later on it is going to work that way or not. Okay, so now you can see Archicad. And basically, this is what I mentioned to you, that here we have the building, okay, a very simple one. And we oversimplified it in a way that you can see that inside we don't have furniture now because it's irrelevant from the energy calculation point of view. So there is a dedicated view in our view structure. So this, I can always get back to this particular view. And then there is this energy model review palette in Archicad, which I can open under design, energy evaluation, energy model review, and all those settings, which I already talked about and which I will mention later on, are also accessible here. But once I open the palette, it's also accessible here. So the thing is that I can have this wireframe view, take a look at my zones, the rooms, and show the unused zones. So this one is interesting if something is not added to a thermal block. So for example, here you can see that there is a room and that gets highlighted. So basically in different visual confirmation what are that belong together. I can create new thermal blocks and I can add zones thermal just easy as that. Remove this. You can see that if there's, I show unused zones. If we want these, then I can choose to add the one that is not assigned yet. So now the shaft is added back. But anyways, the thing, what can happen here is that from a modeling point of view, my model might not be correct. I'm in a different phase, which is suitable maybe for the energy evaluation. So what is important is to show if there are uncovered areas or not. So for example, in this case, there is a curtain wall that has a full face, and this part is not going to be considered in the energy evaluation as of now, probably because the zone behind it is not touching it. So this is something that needs to be fixed in the model. But then there are also going to be small ones like these, which we can think about whether it's worth considering or not really. Actually, this is within 2 or between two internal zones. So this is not something that is that serious. Maybe the one that should be considered is this, because this is facing, or this is touching an external surface, but it's relatively small, so this could be ignored as well. I'm not going to fix it now, but basically this is what you can see, and this is what you set up first. So what I mentioned is that, let's say there is the habitation thermal block. You can see that these are different systems that we're using. If I remember correctly, this one is, let's see. Yes, this is Germany. So we have 4 seasons here. That's why we have heating, cooling, and 2 types of ventilation as well. And here, okay, if you look at the operation profiles just for the habitation, okay, then you see that habitation is residential habitation profile. So maybe we can check what that means. So we can differentiate the weekdays and the weekends. And in case of the weekdays, we can edit the daily schedules. And during the early mornings and the evenings, we have 20 to 26 degrees. Then it's 18 to 28 in the middle of the day. Strangely, we're not using any equipment during the day, but we're using equipment outside the working hours. Well, it depends. If it's a regular apartment and we go to work, we go to the office, then obviously there is very minimum energy usage. Probably there's still something from the equipment, so something should still be here. But this was the idea behind this setup. Okay, so this is where we were. So I will just go back to the presentation. And then again, I have to share once again. Sorry about this, but it seems like that we just got tricked by technology. Okay, so these were the energy related inputs, the internal requirements, and so on and so forth. But what happens after this? So what is the actual energy model? So what AutoCAD can do is to check the building geometry, what you have modeled, and what are the materials, what are the physical properties of the envelope itself, and how that is connected to the space boundaries. So basically what you see is that there are the zones that I mentioned, that they are part of the thermal blocks. The zones are going to be the logical connection between the external conditions and the internal requirements. As an architect, what we can do is change the structures and change the openings. And on the openings, we can run solar analysis. And I haven't edited here, but later on, we can also add in more details related to the structures as well. So let's see these parts. Structures. Also based on the zones, okay, the next page in the energy model review is going to be the structures. So every element that is a boundary of the zones of the rooms that we have is going to be listed here. Some are going to be theoretical ones, and they are in this case called virtual boundaries. So, for example, boundaries between 2 adjacent zones that don't have a physical boundary. But there will also be, most of them are going to be actual real boundaries. And then here we can use what type of structure was used and the performance, the energy performance of that structure. And in this case, I think the most important thing is the U value. This is what is set as a requirement in most of the cases. The good thing is that if we have our structures with actual building materials, then we are also going to have the U value automatically calculated based on the physical properties. So we don't have to do anything about this. However, it can happen, especially in the early design phase, is that you are not using the actual building materials. You are just using a generic building material, a dummy building material, which doesn't represent the real physical attributes and the real physical performance of what is going to come later. So in this case, how can I use something imaginary to get exact results? Well, in this case, it's possible to manually override the U value. So for example, if I have a dummy structure and the U value is nowhere near the required standard, then I can just say that, okay, I'm just going to put in this case, 0.28. And whatever I'm going to do later is going to fulfill these requirements. So for now, I'm just kind of making a commitment that I don't know what it is, but it is going to perform this way. And if I use this later on for the calculation, I can use it to define the demands. So how much energy is actually going to be needed to operate the building. So this was the first thing, the structures. And the second one is the openings. Similarly, the zones are going to recognize the elements that are available on the boundaries. The doors and the windows, and in case of the roofs, the skylights. And the openings will also have their own physical properties, which we don't have to know all of these things ourselves. But basically, whenever we have an opening, we can open the catalog and choose what the opening is made of. So what type of glazing and what type of framing it is made of. So here we have real life options and items with real life physical properties. These are given. So you just pick what type of openings you have, and then you're already going to have an actual opaque U value, an actual glazing U value as well. Okay, this one, the next, would be defining the building systems. But again, we're just in the very beginning of the process. So we have no idea what the building systems be. So in this case, at least as an architect, we can say that knowing the climate and reading the climate data, as architects, we will be able to decide that whether we are going to use heating or cooling or both, or what types of ventilation systems we're going to use. So these can be put in, at least their names, but we don't have to specify them. We're just going to say they are not yet specified or natural. So again, what does this mean? Is that we don't know what it is, how it works, but we say that it is going to fulfill the requirements. If there is the energy demand based on the requirements and the environment, these building systems will fulfill those demands. We don't know what are those, but they will work. And in this case, if we have this approach and this concept, it means that once we are done with the energy calculation, it is actually going to show us the demand, how much energy is needed, how much energy we need to provide for our building. Okay, so first, we can use kind of placeholders to get the demands of our building. Okay, and this is going to be basically the result of the energy evaluation. So maybe here now I can just probably switch again to Archicad and then again reshare with Archicad just to show you that part as well. Okay, so when you are here in Archicad, this second page is the structures. In all these pages, you can choose within doing a tree view or a list view. For structures and openings, it's probably the list view that is more useful. And again, here when you select the different types of different items, then it shows you in the model where those things are. Openings, very similarly, they are going to be highlighted in this system as well. Okay, and basically this is what we do to start the energy simulation. What you see here is going to be more important later on when we do comparison. So if we do comparison, then we can already use an external baseline building. Here in this case, we're not going to do that. I will just continue. Usually before every evaluation, we have to do a final update just to synchronize everything. I'm not sure how much it's going to take. It should be pretty quick, but basically it is going to give me the report sample, or kind of a sample of the report, where I can choose what types of chapters I want to include in my building. Okay, just checking how we are doing with the time. So far, I think more or less okay. All right, so that's the thing. So here is the evaluation report. And there are some format-related options. So, to change a little bit the style of the headers and things like that. But actually, what is important for us is what are the chapters that are included. So one thing can be key values about the overall project. Most important is probably the heat transfer coefficient, the U value for the building shell itself. So the overall building has to perform in a way. I'll just make this a little bit bigger. So this is going to be very important. What is also going to be very important here, the primary energy and the emissions. So this is what we're putting on the environment, and this is what we're actually using, the total net energy. This is what we're actually using. You can see that actually it's more than twice the energy is needed from the environment. This is an interesting 1 degree days, is more describing the environment. So heating degree days is when it's heating requirement. If I just want to, there's a formula how it is calculated, but it's a little bit complex at first sight. So I will just oversimplify it and say that basically heating degree days is the number of days, or actually, when we are we need heating, and cooling degree days is the same when we need cooling. We can have the project energy balance, so what goes in and what goes out. So you can see solar gain, human heat gain, that is supplying energy. But there is also the energy that goes out through the gaps of the windows, or depending on the structure types. Obviously, concrete is not going to have infiltration, but lightweight structures will have more. So these are interesting graphs to compare what contributes to the supply, what contributes to the losses. And then you can also break it down to the different thermal blocks, right? So here, how the different thermal blocks work. Obviously, the one habitation that has the big glazed surfaces, that has a lot of solar gain. Kitchen that is at the back of the building doesn't have solar gain, but lighting and equipment will contribute to energy consumption. So these are the things, and I think probably these are the most important ones. The daily temperature profiles, these were the demands which we were setting up in the operation profiles. And here on these graphs, we can see how they are going to be fulfilled, if they are fulfilled by our building systems. So externally, there's a very low temperature. Internally, we keep it as a minimum. And then here, because we have more room to work with the temperatures, we can even let it go lower. At this part, this is going to show up as a so-called unmet load hour. So it means that the requirements are not fulfilled. So in this case, we can consider that heating rising here is going to start a little earlier. Or we can just say it doesn't matter. We can live with this. We can choose different dates for the same thermal block. We can use it for all thermal blocks, so we can have a lot of these and use it as a first evaluation, right? So here we're not even comparing anything. This is what is important, that we can get the design data. So here you can see that this is going to show up as heating demand and cooling demand. So this means that what is the peak demand? This is what we will have to provide with our building systems. So when we define the building systems, then I will have to consider that it has to provide at least 3.6 kilowatts of performance. So if the minimum that we can buy as a heating system for habitation is 5 kilowatts, then I'm going to put in 5 kilowatts into the specified building systems. Okay, I hope that makes sense. Yeah, I'm not going to go into these for now, but go back to the presentation. Okay, so I'm just going again. Okay, so here is the energy evaluation. Okay, the pages that I just mentioned, daily temperature profiles, and the design data. So this was the very first thing, and we have actually completed 3 steps. So here comes now the optimization itself. So we created the baseline building with the not yet specified building systems. We did the simulation. So in the table, you could see what is the demand, and we take a look at the whole report and review the energy performance. So we know what contributes to the energy consumption. So now how we're going to improve this. First, we're going to take a look at what are the different options that we should use. Should we use renewable sources? Should we use shading? Should we use solar panels? What is the right solution? Once we have our different solutions, then we're going to execute sensitivity analysis. This sounds very scientific, but basically what it means is that we're going to run the energy evaluation again and again and see which one has the actual biggest impact or the best impact on our design. So we'll probably come up like maybe 5 or 6 optimization options, and it turns out that 3 of those options are actually going to work. So that means that we determine the project-specific low energy solution set. Okay, so we pick from a few options, we pick a few actual ones. And these can be architectural solutions, these can be changes in the building systems, or we can use renewable resources. So after this, we're going to define the building systems with the actual values and performance, and we run a final energy simulation. So this means that now our improved design is having actual values, and we're going to see how much or how well it goes beyond the performance of the baseline building. How much did we improve? Okay, so let's take a look at this. Investigate optimization options. So there can be 2 approaches, active and passive. So active means that we're working on the building itself, and passive is that we're working more with the environment itself. Okay, so there are going to be a lot of active ones. Usually these are the easiest to do, to change the design a little bit. And basically, if we look at the different types of climates, then we can have cooling dominated, heating dominated, mixed cooling and heating. So for example, the sample building that I show you in Archicad is mixed cooling and heating because it's Germany. If we look at Indonesia, then that should be considered as a cooling dominated. So you can see on the left side there are three groups: passive solutions, energy efficient building system solutions, and renewable energy systems. So some of the renewable energy works. So photovoltaics works, so to use thermal energy to create electricity. That works pretty well. But all the others, they don't really help, right? So we need to deal with cooling, and the renewable sources and improved building systems mostly help with the heating. And this is what you can see also here. So what we're going to look at when it comes to the Southeast Asian region is that we're going to optimize the building shape, the form. We're going to use better construction types at the envelope, better insulation, solar shading, use natural ventilation, for example. Okay. So this is going to one thing, and the other thing which we should consider is efficient office equipment. So LED lights, replace devices more frequently to have lower energy consumptions, things like that. Okay, so we are going to basically go through the same settings as before, but now we're going to change them. So first, you could see that it was fluorescent lighting tubes given as a default for the baseline building. So we can change that to LED light. And if we know exactly how much is the wattage of the equipment and how much we can improve there, probably we need some external parties to help with those numbers. So at least an MEP engineer, that the numbers can be changed as well. Okay, the thing that I mentioned already, actually, the structures and the materials in the conceptual phase, we could use the manual override of the U value. We just said that this is going to happen. But then when we are in the design development, we're going to use actual building materials with actual physical properties. And those are also going to have the final U value. In case of the structures panel, there's a very interesting thing that you can use 2D detailed drawings to be converted to linear heat transfer values. So basically, we can see that there is a connection of the curtain wall to the ground slab. So in a heating dominated environment, but also in a cooling dominated environment, there is a heat transfer through the frames. So that's why it's good to have it insulated. And this heat transfer is happening through all the way the front facade. So we can say that this linear heat transfer happens at 6,300 millimeter length. So just the bottom part, let's say, or the side, top, and so on and so forth. So we can all use those detailed drawings and create these linear heat transfers. This is going to add more accuracy to our calculation, because normally the calculation is simplified in all cases, not just within ArchiCAD, but the calculation is only considering that there's a requirement here, there's an environment here, what is happening here in between. But it's not considering these different linear gaps, basically. So what we can do there is we can analyze the detail, and it is going to give us a colored graphics, which we can use and put in next to the drawing. So this is also helping us to explain it to the client. Why are we using this? Obviously, if they see something that is full of red, then they will understand it better that, okay, there is a heat transfer, and this is where they lose money. And this is where the operation is potentially going to have bad results. So this is an additional information to add more precision. In terms of the openings, we can run solar analysis. So if what happens with the shadings, how do these actual shadings modeled elements affect the solar heat gain? Typically, again, in cooling dominated countries, that would be important. So again, you can decide, let's put some more shading if there is too much of the yellow in the graph. So previously we just defined what is going to be the material. Now we can look at the solar analysis, evaluate it, and make changes depending on that. Okay, I'm just mentioning here the cooling systems because that's more relevant locally. But basically, this is where we can make use of some MEP knowledge because it can be MEP heavy as well. There are two options, basic and expert options. So here you can see this is the expert option where I'm going to change from the not yet specified to the local, central, or anything different, detailed settings. So here it is good to know what we should put in. But what matters is that this is the part where you need to set the performance based on the demand calculation. What I mentioned that previously is that if the heating demand, the peak was 3.6 kilowatts, and if I buy a furnace that comes in 5 kilowatt steps, then I will just say that the pellet furnace is providing 5 kilowatts. Okay, but here is another example about the ventilation. So you can choose the different types of components. Again, this requires probably the knowledge of an MEP engineer, but you can switch back to the basic and then it will also be good for estimations. When you use these ventilation devices, then you can also have an operation schedule, which is very similar to the operation profile. But in case of the operation profile, we say that what is the requirement at what times? And in the operation schedule, we're saying how the devices are going to work in the different times to achieve the required demands. Okay, and then here also we can use renewable energy, so wind and solar photovoltaic. If we're using solar thermal panels, that's an option under the heating. Okay, so that's also there, but there we make obviously a difference between photovoltaics and thermal panels. Okay, and the last part, which is going to contribute to the overall calculation related to the environment, is the energy source factors. This is what I mentioned in the very beginning. So how much each of the solutions is weighing in in terms of the impact towards the environment. Sorry. Strangely, there is actually some errors which I took from one of our preset files. So I think 0.20 for wood sounds too good to be true. But actually, in one of the, like for example, in Denmark, because of the district heating, we can consider 0.8 primary energy factor. So that one is valid. This 0.20 is too good to be true. Probably here it was just accidentally changed from 1.2 as for the pallet. So this is an important part. You can leave this as with the default values, or locally you can find the numbers. It depends from region and region, or region to region. And also what electricity is produced from. So this is also something that locally you have to be aware of. Energy costs, you can choose the units. It's just going to be a text. Price, you just have to look up the bills, the energy bills. And this, all in all, will contribute to the calculation of the overall impact towards the environment, and this is going to tell you the yearly energy cost, how much you have to pay to operate the building. So this is going to be really useful to have these numbers. And basically, this is what happens at the last part that you can compare with the baseline building. So in the report, you can see that this is the cost. So in this case, it is British pounds per year. And when you apply the renewables, then you have a summary of that, how much energy you generate with the renewable. There are some advisory messages. You can see the unmet load hours. This is the one that I mentioned, that we don't, the machines, the devices are operating in a slight delay, so they don't fulfill the requirements immediately. And here, this is the comparative table, so that you can see that this is what you actually use. This is what you generate with the renewables. So it means that eventually the cost is going to be this. So the original baseline building was this, and the new is going to be this, which means that cost-wise you spare 82%, energy usage-wise 64%. Obviously, it depends on what type of energy you use again. So these two will not be the same. Okay, and here is another one. The energy simulation is referring to the ASHRAE standard, which means that we have to evaluate the building at its original orientation, but we also have to rotate it 4 times, do the evaluation, and take an average of that, and that is going to be the final result. So this is just the method of the test. That's why you will see here 4 different orientations. And then eventually there is also this performance rating table. Again, for different types of energy usage, you can see how the proposed compares to the baseline. And it's very interesting that on the heating, we're actually losing. So it's not a good solution that we have in terms of heating, but we save so much on the others. So for example, in case of cooling, you can see that from 15,000, we save almost down to lower than 2,000. So the almost 90% saving is much more outweighing the inferiority of this the heating solution itself. Okay, so anyways, here you can see what type, where do you improve the most, and where you're not improving. So I think this is pretty useful, and this is very easy to show to everyone, and they can understand that, okay, there's actually a result here. There's a reason why we're doing things like the way we do. Okay, I'm going maybe a little faster, just so that we're not running out of time. How can we share this information with engineers? The thing is that Archicad will support your design decisions and make sure that you have reliable data, but it's not going to do the actual certification. So there is usually an engineer who is doing these certifications. The thing is that you can share the building energy model information through the GBXML file format. This is a green building XML, a free, open and free XML schema. It's basically the quasi standard for building analysis tools to communicate. So we can just export the building energy model in this format, and they can do the actual certification. There's another export format which is more related to Germany, Passive House, which is an Excel sheet basically, and we can just generate the input for this PHPP, the Passive House software. So, okay, I told you a lot about the methods and the reasons why we're doing it, but is this reliable? As I mentioned about the 4 orientations, we have the ASHRAE certified simulation. So ASHRAE is the American Society of Heating, Refrigerating, and Air Conditioning Engineers. And basically, this organization is doing research projects. But the most important thing is that they develop and publish the technical standards to improve the building services, engineering efficiency, indoor air quality, and sustainable development. So they provide the technical standard. And in this case, the technical standard means that one of the aspects is that they also examine the different building analysis tools. So here, okay, it's not that distinguishable, but actually the red one is EcoDesigner Star, as we call the engine within Archicad. So here you can also see EDS, the red results, and you can see that it's pretty much the same or very near. All applications are very near to each other. So it is just as reliable as any of the other applications that we can find here in the list. So I think that's good news. So feel free to use it. And basically, okay, how well known is this thing? And what are those tools anyways? So basically, the simulation is the whole method itself, which is referenced by most of these major sustainable building design regulations and the national standards which endorse and use and refer to dynamic simulations. So there are all these different types of rating systems in Australia, US, UK, and Japan. So Green Star and the Nationwide House Energy Ratings Scheme. Those are ratings in Australia. LEED is probably one of the best known ones. BREEAM from the UK is one of the oldest ones. They are all referring back to the ASHRAE testing and certified and the simulation methods themselves. Okay, so that's why we are also referring to that as well. So all in all, our goal is to make the best design decisions from the early phases and make sure that this is as easy as possible. I hope you see the benefits and understand now how it works and what is the concept behind it. And by that, I just came to the end. So thank you for your attention. I'm looking forward to the questions and the Q&A later on. Okay, so I'll just hand it back to our MC.
Okay, so first things first, we would like to thank Mr. Sandor Bali for delivering the materials that opens up our new insights for each and every one of us. So as already explained before, that in green building design, there are incentives and deterrents. While the incentives are required by the author for certification, make better design decisions, and have a competitive advantage, etc. While the deterrents are too complex in general, it is not suitable for architects and needs additional software where there are more time and energy spent. Then it continues to the building life cycle, which has raw material acquisition, manufacturing, construction, operational, which is the main environmental impact, repurposing, reconstruction, and demolition. There are higher energy usage in acquisition and construction compared to the maintenance. And while the operation has the longer times, which is almost 50 years. And then there is the energy analysis workflow, which is the model preparation, which leads to energy-related data input, leads to the BM generation, and then to the energy performance evaluation, which will improve design and improve the BM, which also improve the energy performance evaluation and leads to BM export to certification. While there's also the optimization workflow, which can create baseline building without the system, run energy simulation, which demand calculation, review energy performance, investigate sensitivity analysis, determine project-specific solution, define building system, and run energy simulation, which will be compared to the baseline building. While there are also optimization approaches, there are two methods to do that. That is active, which isolates from the environment, and there's passive, which cooperates with the environment. Baik, tapi ucapkan terima kasih banyak kepada Bapak Sandor Bali yang telah memaparkan materi yang sangat membuka wawasan kita semua. Jadi, seperti yang dijelaskan sebelumnya, bahwa dalam Green Building Design ada beberapa keunggulan dan kekurangan. Untuk keunggulannya itu akan bisa untuk sertifikasi, dapat membuat klien terkesan, membuat keputusan desain yang lebih baik, dan lain-lain. Untuk kekurangannya, itu akan terlihat terlalu kompleks atau rumit secara umum, kemudian akan membutuhkan perangkat lunak tambahan, di mana itu akan membutuhkan lebih banyak tenaga dan waktu. Untuk siklus pembangunannya itu akan dilakukan dengan mengakuisisi bahan baku, dilanjutkan kepada manufaktur, kemudian konstruksi, dan dilanjutkan kepada operasi yang memiliki dampak terhadap lingkungan. Kemudian akan menggunakan kembali rekonstruksi dan akan pembongkaran, di mana penggunaan energinya tuh akan lebih tinggi pada tahap akuisisi dan konstruksi dibandingkan dengan pada tahap operasinya. Di mana operasinya itu akan memiliki waktu yang lebih lama, kurang lebih 50 tahun. Kemudian untuk workflow energi analisisnya itu akan terdiri dari persiapan model, dilanjutkan dengan inputan data, seperti informasi iklim dan lingkungan. Kemudian akan ada model informasi bangunan, desain dasar, dan evaluasi dan membandingkan opsi desainnya. Kemudian untuk workflow yang dapat mencapai keoptimalan akan dibuat bangunan dasar yang tanpa sistem, kemudian menjalankan simulasi energi, meninjau kinerja energi, menyelidiki analisis sensitivitas, menentukan solusi kursus proyek, menentukan sistem bangunan, dan menjalankan simulasi energi dengan dibandingkannya dengan bangunan dasar. Kemudian untuk pendekatan keoptimalannya akan ada dua cara, yaitu secara aktif dan pasif, di mana pendekatan optimal secara aktif itu akan diisolasi dari lingkungan, sedangkan yang secara pasif akan bekerja sama dengan lingkungan. Selanjutnya kita akan masuk kepada sesi tanya jawab. Namun sebelum itu akan saya bacakan kembali SOP-nya, di mana para peserta yang memiliki pertanyaan terkait materi yang sudah disampaikan pada sesi ini dapat ditanyakan ke dalam link Slido yang sudah tertera di layar. Dan jangan lupa juga untuk menuliskan nama lengkap dalam Slido untuk mendapatkan kesempatan memenangkan door prize. Baik, mari kita mulai sesi Q&A kita. So let us start our Q&A session. For the first question, it is from Franz Sinaga that asks about, do we need another software to design and evaluate authentically about environmental inputs?
Okay, so for the environmental input, that one is good enough if you have the external source of the EPW files, or just use the built-in ones. So that will give you all the information about the environment. Evaluate authentically, so that's the part, if you're looking for the results only, then you can see that the results are, so we can trust the results. But if you want certification, then you need to have another software and another expert who can do that. So evaluate authentically is a little bit broader than that. But if you just want to have the results and you want to have reliable results, then you don't have to use other tools.
Okay, thank you for the answer, Mr. Sandor. Kepada saudara Franz, apakah pertanyaan tersebut sudah terjawab? Baik, untuk selanjutnya akan dilanjutkan dengan pertanyaan dari Franz lagi, yaitu what kind of description with 6D models that can know energy analysis workflow that relates to the disposal of waste material building?
Okay, I think so this part is not included, the waste disposal. So that one is unfortunately not included. Actually, there are many fields which are not included in that sense. So it's basically that part which is mostly affecting or has the most impact on the operation and maintenance, the actual structure itself. But like what happens during the construction, how much energy is used for the actual construction, or how much energy is used when we're demolishing the building, we are not calculating that part.
Okay, thank you again for the answer, Mr. Sandor. Untuk Saudara Franz, apakah pertanyaan tersebut sudah terjawab lagi? Baik, akan kami lanjutkan kepada pertanyaan selanjutnya yang berasal dari Abdul Aziz Setio Purnomo. So, how to differentiate 4th dimension, 5th dimension, and 6th dimension? What other components are collected in the 3 dimension to 6 dimension? Well, as we know that energy is an invisible form, so how can the BIM accommodate this?
Okay, so I guess the first part is more a generic thing, like 4D and 5D, those are cost and time, and 6D is the sustainability. So basically, I guess probably this question came in the early part of the presentation, but so in 3D, what we look at is the building envelope. So all those constructions, basic elements that we actually model as architects. So if we are just very much simplified, then slabs, walls, doors and windows, which are between the rooms and the environment. So how can we connect this and how we handle the invisible form, as it's mentioned in the question? That's the thing, that we have the environmental information from the climate files, and we have the internal requirements in the thermal blocks. So we use the zones, we group them into thermal blocks, and in the thermal block, we say that this is going to have this requirement that the building has to fulfill.
Okay, thank you for the answer, Mr. Sandor. Untuk Saudara Abdul, apakah pertanyaan tersebut sudah terjawab? Baik, akan kami lanjutkan untuk pertanyaan berikutnya dari Jajan Jayana Mutakin. Could the architect environment energy evaluation offers an easy-to-use workflow for performing dynamic building energy calculations on projects of any size?
Okay, so the workflow would be the same that I showed today, so that we have a baseline, we improve it, and then we compare with the baseline. Of course, after some time, we can take shortcuts because we know what types of solutions, improvements work the best in a certain location. But the workflow would be the same. And actually, you can use it on any size. So it may depend. I mean, workflow wise, you might split the live working model for architecture and the building energy model. So I'm saying a very simple example. You can have a copy of the file at that point and do the energy evaluation on a simplified model, because the architectural model can be really heavy at some time, at a certain point, especially a bigger building. And as I mentioned, we don't need everything for the building energy model. So if we have the initial information in the architectural model, which includes the environmental information and the requirements, then we can maybe split this process. We're not going to do the energy evaluation as often. So at certain stages, we can just split the workflow and create the energy evaluation in a lighter file that only contains what's relevant for energy evaluation. So that's how we can tackle the large project performance issue, for example. But the workflow would be the same.
Okay, there is the answer for the question. Untuk saudari Jejen, apakah pertanyaan tersebut sudah terjawab? Baik, sekarang kita akan melanjutkan kepada pertanyaan selanjutnya dari Rafael LB. How to anticipate the ever-changing data, for example, the climate, so the energy analysis workflow can provide us the most accurate data for the future?
That's a very interesting question, actually. Well, I guess it all depends on how frequently these weather files are updated. Which honestly, I don't have a benchmark of that or cornerstone to tell you whether they update it every 5 years or every 10 years. I guess, well, we're seeing averages of a certain time frame. And honestly, I cannot tell either that those time frames are maybe 5, 10, 25 or 50 years looking back and giving you historical data about the environment. So I think probably here the best approach is trying to get all these files from the most authentic source, like what I mentioned, the U.S. Department of Energy website, because that's if that is not updated, then probably it's not updated anywhere, right? So in this case, probably we have to rerun the analysis from time to time if that's still an issue, or maybe taking today's situation into account that energy prices have risen. I can just run the energy evaluation with the increased prices, so I can see that this year it's going to cost me that much to operate the building. But to run a single analysis and consider the potential changes in the climate in the future, we don't deal with that at the moment. I don't think anyone really does. But it's a really interesting and valid question.
Baik, untuk saudara Rafael, apakah pertanyaan tersebut sudah terjawab? Oke. Untuk pertanyaan selanjutnya, ada pertanyaan dari Dias. The problem when using ArchiChat is that we can't make the rebar. We must use another program as plugin like Aptar. So how to solve this problem besides use the plugin?
I'm not sure how this one is directly related to energy evaluation, but probably this would also be a thing that we would exclude in the energy evaluation. So rebar, and especially I know that in Aptar you can create those very detailed rebars, but actually they can really make the project heavy. So typically we use them on very standard details of the building and not throughout the whole model, because for a high-rise building it would just create so many polygons that it would be impossible to handle. But even from an energy evaluation point of view, the composite structure or the concrete structure that we're using in the model without the rebar already contains the physical attributes of reinforced concrete. So rebar is not needed when we do the energy evaluation. So I can't really see how these two are connected in this case, but yeah, we don't need the rebar.
Okay, thank you Mr. Sandor for the answer. Untuk Dias, apakah pertanyaannya sudah terjawab? Baik, mungkin sudah terjawab, cuman belum tersampaikan. Untuk melanjutkan ke pertanyaan selanjutnya, ada dari Dedi Tandi Limbong. Apakah program ArchiChat bisa menghitung kebutuhan AC dan lampu, serta apakah bisa mengkoreksi desain yang tidak green building? Terima kasih. So basically what he's asking is, can the ArchiChat program count the needs for like the example like the air conditioning or the lab usage, and can it correct the design that is not green building, like the design of the green building like that, sir?
Okay, so it doesn't know the standard. So it will not tell you if you have a result that this is good or wrong. So you need to know what is a good result. And that's why we can use, for example, the U value override, because that's always a local requirement. So I should know what is considered as a requirement locally. About the design, so not every system can be designed. So for example, heating, so it's not, the goal is not to design MEP systems in a sense with this one. The only design related part is that when we run the evaluation in the early phase and we say that it's not yet specified, then it is the result is going to give you the demand. So you know how much you need to provide. So that's the only part that is design related. Okay, but that's more about the heating performance, the cooling performance. Air condition, it can also be included because that is also considered cooling in this case. So we have a cooling demand. You say that the cooling is air conditioned, not yet specified. Then you have a cooling demand. You use that number to put back into the actual system. And then basically that's the system that you have to have the minimum.
Okay, thank you sir for the answer. Jadi apa yang dibilang oleh Bapak Sandor tadi itu bahwa tidak semuanya bisa dibilang itu adalah good result. Jadi good resultnya itu merupakan relatif lah istilahnya. Dan tidak semua sistem itu bisa didesain karena hal-hal tersebut. Oke, selanjutnya ada pertanyaan dari Antonius Yogi Nugra Prabowo. For implementation on field project, what energy elements will be generated from this software? And what are the functions and what's the impact for the design or the cost?
I'm not sure if I understand energy elements. So what those are referring to? Well, I think I mean, there are the energy consumptions of the different rooms, overall energy balance of the different rooms or the whole project. The cooling energy or cooling, heating demands, primary energy, net energy, carbon dioxide emission, these ones.
Oke, untuk saudara Antonius Yogi, apakah pertanyaannya sudah menjawab?
I guess this may have been a translated question, and in that sense, but maybe the translation was a little bit off. So if you can give more details, then please do so.
So what he meant, sir, is what kind of output that is generated from the software.
Okay, so for the output, we have the PDF of the report. We can have the PHP file for the passive house method, and we can have the GBXML, which is for the information exchange with the actual energy professionals who can do the certifications.
Also, here's another question, sir, that what kind of impact that is given by the design towards the cost of the project?
Yeah. So what? Okay. So what is the impact? That's what we see from the reports, right? So there were those three groups that I showed, that there are different types of solutions for cooling dominated countries. The building system solutions, the passive solutions, the renewable energy solutions. So all those have a different impact, but how much they actually impact our actual building, it will always depend on we will only see that in the report. So because the amounts where we can use those improvements are always going to be different. So that the impact on the design will always depend on that, and we can see that in the report. And cost-wise, we can use these performance rating tables that I showed in the very end, which is going to give you the yearly cost difference between the baseline and your design versions.
Here's another additional question, sir. So due to the limited time, so this will be our last question for this session. So what if we use the BIM 3D model that we found clash detection on superimposed model? Then we need to redesign until we do not found it.
Yeah. Okay. Okay. So the clash detection, I guess the clash detection is now here just brought as an example. So based on the clash detection, we need to redesign. We can redesign anytime and update the review, the energy model review. So that only means that in most cases, the zones will update and be applied in the new situation. But again, this would also be in a way different from the clash detection part, because, for example, in an energy model review, you would not necessarily need to use the beams in the slabs, because within the building, the beam is not going to take part in any of the energy consumption, or so that way you would exclude that. So the building energy model can be much simpler, and therefore it might not even need that much of a redesign. I mean, the redesign might not even impact that, because if, let's say, from a clash detection point of view, you have to move internal beams or internal walls, that's a very minor things. Beams you wouldn't even include in the original calculations, and if you move internal walls, then you would just update the zones so that they will match the surface, the external surfaces.
Okay, thank you for the answer, Mr. Sandor. So that question marks the end of our Q&A section. So thank you very much to Mr. Sandor for answering the participants' curiosity very clearly, and all of the participants for the enthusiasm. Hopefully, this session deepens our understanding of BIM's 6 dimension and its potential usage to help us manage our infrastructure and monitor its energy consumption in order for us to achieve sustainable society. Baik, karena pertanyaan tadi merupakan pertanyaan terakhir pada sesi tanya jawab kali ini. Terima kasih banyak kepada Bapak Sandor Bali yang telah menjawab rasa penasaran peserta dengan sangat jelas dan partisipasi aktif para peserta tersebut. Semoga apa yang disampaikan ini dapat memperdalam pemahaman kita semua terkait dengan BIM 6 Dimension. Harapannya adalah tools ini dapat membantu kita untuk memanage infrastruktur fisik demi mencapai kehidupan masyarakat yang berkelanjutan. Nah, kemudian acara selanjutnya adalah pengumuman mengenai asesmen untuk peserta workshop sesi 2, yaitu peserta akan mendapatkan asesmen yang berupa pertanyaan di Google Form yang diberikan pada akhir sesi. Peserta akan diberikan waktu 1 kali 24 jam untuk mengisi form asesmen yang diberikan. Asesmen tersebut dapat diakses pada link bit.ly/assessment_ICE 2023 XRTchat. Peserta juga diharapkan untuk tidak menyebarkan soal maupun tautan asesmen melalui media apapun. Peserta diwajibkan mengisi asesmen untuk mendapatkan sertifikat asesmen. Jika terdapat pertanyaan terkait teknis asesmen, peserta dapat raise hand dan on mic setelah dipersilakan oleh MC untuk bertanya. Baik, acara selanjutnya adalah salah satu acara yang paling ditunggu, yaitu pembagian door prize yang berupa 2 mouse wireless yang dipersembahkan oleh Piranusa. Well, coming up is one of the most awaited bits, which is the door prize session. We'll get started with the spin wheel. Untuk pemenang pertamanya, selamat kepada Saudara Rizky Robi Rahman Alam. Kepada Saudara Rizky, diharapkan untuk dapat menghubungi langsung kepada Saudara Stephen. Kemudian, sekarang kita akan mengundi terakhir untuk melihat siapakah yang akan memenangkan door prize terakhir kita pada hari ini. Selamat kepada Saudari Dia Kartika Indriadi, kepada Saudari Dia dapat langsung menghubungi Saudara Stephen untuk mengklaim prize-nya. Dan untuk Saudari Dia dan Saudara Rizky Robi tadi diharapkan untuk dapat raise hand terlebih dahulu. Oke, baik. Acara selanjutnya akan selanjutnya akan dilakukan penyampaian sertifikat untuk pembicara pada hari ini, yaitu Bapak Sandor Bali oleh Ketua ICE 2023, Mas Romi. As a form of appreciation, honor, and gratitude, we are proudly presenting today's speaker, that is Mr. Sandor Bali, a certificate. It will be delivered by ICE's project officer, that is Mas Romi. For Mas Romi, we welcome you to give a brief remark.
All right, thank you, James. So, good afternoon. I'm Romi Putradiansyah, the project officer of ITB Civil Engineering Expo 2023. So, thank you, Mr. Sandor Bali, for the knowledge. Hopefully, we'll still collaborate in the future to make a greater impact for the civil engineering industry, especially in Indonesia with ICE. So, once again, thank you very much.
Thank you very much. It was a pleasure to be here. So I hope we meet soon.
Okay, so this special occasion will be documented on my cue. So, prepare your biggest smiles. So we will count it on like 1, 2, 3. Oke. Tibalah kita di pengunjung acara pada hari ini. Namun sebelum menyudahi sesi workshop pada hari ini, akan dilakukan sesi dokumentasi untuk peserta workshop dengan aba-aba dari saya. Jadi untuk para peserta workshop diharapkan untuk dapat on cam. So we have arrived at the end of this event. So thank you very much, Mr. Sandor Bali, as the speaker of this workshop. But before that, there will be a documentation session for the workshop participants. So hopefully all the workshop participants can open the camera and we will begin the documentation session. Untuk sesi dokumentasi akan ditunggu sampai 3.12 ya untuk on cam guys. Oke, karena ini terdiri dari 8 halaman, akan dimulai terlebih dahulu dari halaman pertama. Jadi, untuk para peserta di halaman pertama, dalam 1, 2, 3. Oke, selanjutnya untuk halaman kedua, 1, 2, 3. Untuk halaman ketiga, 1, 2, 3. Oke, karena yang lain tuh off cam, akan baik. Sebelum ditutup, kami ingatkan kembali kepada para peserta untuk mengisi form feedback yang telah di-share di kolom chat sebagai syarat e-certificate. Kami juga mengucapkan terima kasih kepada Archilantis Seamless Open BIM Solution dan Piranusa Graphisoft Architects sebagai partner dari ITB Civil Engineering Expo 2023. Jangan lupa juga untuk follow dan update terus dengan media ICE 2023, yaitu akun Instagram kami di @ICEITB maupun website dari ICEITB itu sendiri. Oh ya, mungkin kalian penasaran kan kenapa acara workshop ini dilaksanakan pada tahun 2022, padahal acaranya bernama ICE 2023. Nah, makanya nantikan terus rangkaian acara ICE ITB 2023 di bulan Januari, yakni seminar nasional di ITB dan live stream, video podcast, live exhibition dan company session di ITB, virtual exhibition, dan Summit Student Conference Competition Awarding. Nantikan terus dan jangan lupa untuk daftar ya. So, before ending today's session, we would like to remind all participants to fill out the feedback form that has been shared in the Zoom chat com. We would like to also thank Archilantis and Graphisoft for being our partners. Please do keep updated with our events by following ICE 2023's Instagram account that is @ICEITB or our website iceitb.com. Do await our upcoming events for January of 2023, where we will bring you our national seminar, which is on the spot and live stream, video podcast, live exhibition, and company session in ITB. And last but not least, Summit Student Conference Competition Awarding. Please do keep in touch. Baik, sekali lagi saya James, mewakili seluruh panitia yang bertugas, mohon maaf jika ada kesalahan kata maupun perbuatan selama keberjalanan workshop ini. Sekali lagi saya mengucapkan terima kasih untuk Bapak Sandor Bali sebagai pembicara dan para peserta yang sudah mengikuti acara workshop pada hari ini. At last, myself James, on behalf of the entire committee in charge, we would like to apologize for any mistakes in our words and our deeds during the course of this workshop. So thank you very much for attending our workshop. Wassalamualaikum warahmatullahi wabarakatuh.